This is from Algebra and Number and Algebra in your MSSL book. It's topic 1, and what we're looking at now is number classification notes. You also worked on this early in your Algebra 2 classes. Now, what we're looking at is we have real numbers, a set of real numbers, and we're using a nested Venn diagram to show sets and subsets, and this is going to come in very handy when we get into the Chapter 8 portion of the text that deals with sets and subsets, etc. So you have the real number system. Within the real number system are rational numbers, and within rational numbers you have specific rational numbers that are integers, and if you have within the integers and also rational numbers, you have natural numbers, which are 0, 1, 2, 3. Also within the real number system, you have irrational numbers. And basically, irrational numbers are numbers that do not terminate or repeat. And so they'll be, when you put them into your calculator, you will get this number, this decimal that goes on forever, just as pi does, 3.14 and so on. So if you were to take the square root of 2, which is an irrational number, put it in your calculator, you would get this really long decimal amount, and none of the values would be repeating, and it would simply be truncating the numbers where the calculator display ended. We're not going to deal much with irrational numbers except to say that you need to be able to identify them. And numbers that are not within the set of irrational numbers would be your imaginary numbers. We don't do much with imaginary numbers. However, it's good to know that there are this set of imaginary numbers. Okay, going back to the rational numbers, let me just one more time talk to you about this idea of the nested Venn diagram. A natural number is a very specific kind of number like 0, 1, 2, 3. Natural numbers are also integers. You can see it right here in integers, and they're also rational numbers. So the natural numbers, if you will, are the lowest or the smallest subset. Now, just a quick note. If you are in the American system, natural numbers do not include 0. They have a delineation called whole numbers. Natural numbers are counting numbers, and in the U.S. system, it would be 1, 2, 3, 4, and so on, going up by 1. And whole numbers would be, the difference between natural numbers and whole numbers would be that 0 would be included. But for the IB purposes, natural numbers will include 0. So don't be confused if you encounter that. Okay, with that said, let's go down and create some more natural numbers. So today in class, I had you go through and write other examples of Q, Z, N, and irrational numbers. And I want to highlight Q is rational numbers, Z mean integers, N mean natural numbers. There's no specific letter for irrational numbers, so we're not going to worry about that. We're just going to call them irrational. And all of these, rational, irrational, integers, natural numbers, are within the real number system. Okay, so let's go down. Some of the examples you came up with were decimals and fractions, because integers and natural numbers cannot or do not have fractions and decimals. So 3.1 was one of them, 5.7, negative 4/5, 2/3. If you were to take and plug in to your calculator 4 divided by 5, you would end up with 0.8, so it'd be negative 0.8, which is a terminating decimal. 2/3, if you went 2, and this bar again means division, divided by 3, you'd get 0.33333, and that would be a repeating decimal. And terminating and repeating decimals are also rational numbers. Another number that you didn't come up with that you might want to consider is something like 1 5/7. So again, this would be a repeating decimal, and it would have a whole number portion. But these are all examples of rational numbers which are given by the letter Q. Now we're going to go to integers, which are given by the letter Z. And some of the examples you gave because they were integers and we didn't want to include any of the natural numbers in there, we went ahead and used all negatives. So like negative 14, negative 9. Now, you can include 0 in integers, but it's also a natural number, so we won't put it under integers. So anything that's a natural number will also be an integer, and it will also be a rational number. And then let's go ahead. No fractions, no decimals in integers. Let's go ahead and go now to natural numbers. Again, natural numbers are delineated with the letter N, and you did things like 9, 15, 22, etc. So you can see natural numbers are like your counting numbers, but they do include 0 for the IB system. For the US system, 0 will not be included in natural numbers. It will be in a category called whole numbers. Irrational numbers are just basically those square roots that are not perfect squares. So I'm going to come back and put the square roots that are perfect squares. So for instance, you have the square root of 2 up there. The square root of 13, you get this long number that would not terminate or repeat. But if you had the square root of 16, actually let's put it in the next classification. Moving down, let's put that over here. Square root of 16, the reason I put it under natural numbers is because the square root of 16 equals 4. And 4 is a natural number, it's a counting number. And 4 is also an integer. And 4, that makes 4 also a rational number. Again, this is all under all of these, Q, Z, N, and irrational numbers are under the umbrella of real numbers. Another one might be 2 times the square root of 5. Again, you've got that radical symbol in there. Square root of 5 times 2 will give you this non-repeating, non-terminating decimal. You can also have cube roots that are not perfect cubes that would fall under this irrational number, but we're not going to get into that kind of detail. Okay, now finally what I want to work with you on is on the back side of your notes. If you go to the back side, are the if-then statements, which are examples of deductive reasoning. And deductive reasoning is different from inductive reasoning, because in deductive reasoning you use facts, rules, and definitions, whereas in inductive reasoning you're basically doing things and discovering things. So if a number is rational, Q, then it is also a real number. And you're going to want to refer to your Venn diagram as you do this. If a number is an integer, Z, that's the letter that denotes integers, then it's also a real number. I'm going to use the number symbol. And a rational number. This is why we're using the nested Venn diagram. Now what I'd like you to do is go ahead and pause the recording. I want you to try the if-then statement for natural numbers and irrational numbers, and then turn it back on and see how you did. All right, let's see how you did. If a number is a natural number, okay, those are like our counting numbers, and they include 0, we are going to be a real number, part of the real number system. It's also a rational number. And it's also an integer. And again, I want you to really go back and think rational numbers are the letter Q, and integers are the letter Z, or represented by the letter Z. And then finally, we have irrational numbers. There are some ways you can represent an irrational number with a letter, but it's not standardized, and it's not important for the MSSL, Mathematical Studies Standard Level class, so we're not going to worry about it. We just want to be able to identify an irrational number. So if it's an irrational number, it can't be rational, it can't be an integer, it can't be a natural number, but what it can be is a real number, because irrational numbers are still part of the real number system. We're going to use this a little bit more in your MSSL text. That's Mathematical Studies Standard Level text. But now you have a good idea, and you have of what you're doing, and you have this nested Venn diagram to help you. Again, this idea of sets and subsets is going to become important later in the course, so try to really look at the Venn diagram and gain some information from it.